Hi, welcome back to the channel. So in this video we will see the next derivation, that is called as non-inverting amplifier. So we will see the derivation of output expression as well as the gain with respect to the second one. We have seen the inverting amplifier in the first one. We will see the non-inverting amplifier. So how to draw it? The circuit diagram, same. Input, symbol, minus and plus. So here it is V1 and this is grounded, this is R. So here we should write the feedback resistance. It is output, I will call it as RF, right? So here we can call it as point A and we will call it as point B, and we'll see the rest of the things now, right? So how to do this? We should obtain what is V output, as well as we should know what is the voltage gain of this. How to know this? So we should take the concept of virtual ground. From the virtual ground concept, if node A and node B are at the same potential, so we will call it as VA is equals to VB. So I will consider this as V in input. VA is equals to V in, V equal to V in. So from, if I consider from the ground potential, you can make it 0. Suppose if we can make both are equal, VA equal to VB equal to V in. So this is a concept you can take. So this is the first. What is the golden rule number? Golden rule number 2 is virtual ground concept. This is the thing. Next. So we can go for writing the equations from the input side. So we should write from the input side how the current equation is. So we should draw first current. How the current is going to flow? It will move from higher potential to lower potential. Here higher potential, ground is lower potential. So the current will move like this. From here it is going to move like this because there is no current which is flowing like this. So current I will take here, the current I the same to the RF and R will flow like this, right? So if I take the input side, current I is equals to, so the input side means this portion, right? This portion I is equals to, so here it is 0 potential, right? So how I can write now? A. What is the voltage with respect to A? VA minus what is the voltage with respect to ground? 0 divided by what is the resistance? R, right? So I is equals to VA. VA is nothing but what? V in. So V in divided by R. So this is the equation number 1 we can write at the input side, right? So now we will consider the output side. So how to write the output side equation? So output side equation we can write like I is equals to, so here it is. So two nodes, to write the current equation I know the voltage as well as resistance. So here how many voltages are there? So between this resistance, this point is there, this point is there. So it is V out minus what is the voltage here? VA divided by what is the resistance? RF. So from the virtual ground concept, what is the value of VA? It is V in, right? So what I can write now? V out minus V in divided by RF. So this is V in RF, right? So I got two equations now, equation number 1 and equation number 2. So here, next, what is the next thing? So we should apply Kirchhoff current law at which node? Node A, at this node. What is the Kirchhoff current law at node A? Is saying current which is entering is equals to current which is leaving, right? So look at the equation number 1 and 2. Current which is entering is equation number 1, sorry, equation number 2. Current which is leaving is equation number 1, right? So we can make LHS equal to RHS. So we can write the RHS as V in by R is equals to V out minus V in divided by RF, right? So from this, what do you want? Output expression. I want this V naught to be written in the format. So what I will write is V in by R I will write. So from here I will write V naught by RF. Again I will split this and I will write minus V in by RF, right? Then after that, what we can do now? So write in terms of this means, so here I will write V naught by RF at the LHS. So I will push this here so that V in by R plus V in by RF, you will get it, right? So from this, what you can do? V naught by RF as it is. From here, V in common then I will get 1 by R plus 1 by RF, I will get it, right? So here, this V in I push here, V naught by V in into RF, I will push this side into, so here what best I can do now? Here, so you can write here as, okay, so I will write it as 1 by R plus 1 by RF only. Okay. Next, multiply this RF with this. What you will get? RF by R. Multiply this RF with this. So you will get 1. Right. So what is V out divided by V in? This much you will get. So that I will take here again. Right. So here V out divided by V in, I got it as 1 plus RF divided by R. So here it is, output expression can be written as 1 plus RF divided by R multiplied by V in. This is the output expression for non-inverting amplifier, right? So look at the LHS, it is output, V output. That's what we have written, right? So also we can write the voltage gain. How to write the voltage gain? V output divided by V input. If you push this here, what you will get? The RHS 1 plus RF divided by R. So this is the voltage gain. This is the output expression and this is the voltage gain of non-inverting amplifier. You can observe this positive sign is indicating, there is no phase shift between the input and the output, right? So if there is no phase shift between the input and the output, how to draw those waveforms? There is no phase shift means it is 0 degree phase shift. How to draw the 0 degree phase shift waveforms? Input, if the input is like this, so what is the type of output you will get? If it is positive, I will get positive, negative, positive, negative. Same. There is no phase shift between this. So we will call this type of phase shift as 0 degree phase shift. Right? Because of this plus sign. And this overall gain is depending upon this value. Okay. If it is gain, this is the formula. If it is voltage, this is the formula. Right? Because basically what is voltage gain is nothing but output divided by input. What is the meaning of this? V output is equals to A into V in. What is the meaning of this? Suppose if V in is 2 volts, assume that this is 2 volts. What is the output I should get is, it is depending upon the gain. What is the gain? Gain is nothing but 1 plus RF by R. It is depending upon these resistances. Your output voltage is depending upon. Assume that this gain is 5. What is 5 into 2? 5 into 2 is 10 volts. So if it is 2 volts, what is your output expression? 10 volts. Right? So that is the meaning. 5 times it is greater than the input. 5 times it is amplifying. This 741 op amp is amplifying 5 times. Okay. So that is the meaning. So when it is going to be 5 times, if it is 4 kilo ohm, if it is 1 kilo ohm, at that time it is, you can apply 1 plus 4k divided by 1k. 1 plus 4 is 5. When this is the case, at that time it is going to give you 5 times the gain. That is the meaning. So we'll see few more configurations of op amp, summing amplifiers, integrators and differentiators in the next class. Thank you. Stay tuned to this channel, click on the bell icon for the latest notifications. If you have any doubts, put it in the comment section. And this is the portion what we are doing with respect to the first year of the VTU, Introduction to Electronics, Basic Electronics, anything which is associated with electronics and communication, electronics and telecommunication, basic electrical engineering, anything which is associated with the op amp. Okay, not only our university, it is associated to all the universities. Thank you.